Hello, everybody. In today's lesson, we're going to be talking about matter, different types of matter, and how we describe um, different types of matter, categorize different types of matter. We're going to start out today with a definition. Matter is defined in science as anything that takes up space. Now, obviously, that can refer to a lot of different things, so it's important for us to have different categories, different ways of describing matter based on similarities and differences, specifically types of properties, physical and chemical properties. And we'll be taking a look at that in today's lesson here in just a little bit. I want to start out with perhaps the most common categorization of matter, the one that you might be most familiar with, and that would be based on the physical state of matter. So when we describe the physical state of matter, we talk about solids, liquids, and gases. So let's start with the solid state of matter. Matter that exists in the solid state is characterized by a definite shape and definite volume. So we see definite shape and volume being characteristic of the solid state of matter. We take a look next at the liquid state of matter. We still have a definite volume, but we no longer have a definite shape. So we think about what that means. If I pour a glass of water, let's say 50 milliliters of water, that volume is fixed. If I pour the water into a bowl from my glass, I still have 50 milliliters of water, but the shape of the water changes. It takes the shape of its container. Liquid water we're talking about here. You think about pouring the water from one container to another. The liquid takes the shape of its container. So we have a definite volume for a liquid, but do not have a definite shape. And then finally we have the gaseous state of matter. Gases have neither definite shapes nor volumes. So they will expand to fit the container that holds them, and they will also take the shape of that container. So let's say no definite shape or volume for gases. So gases have the ability to be compressed. They will also expand to fill their container as well, and therefore do not have a definite volume. So when we take a look at the properties of matter, they typically fall into one of two categories: physical properties or chemical properties. So let's investigate the difference between these two types of properties, starting with physical properties. A physical property of matter is one that can be observed without changing the sample's composition. So this would be something like color or temperature. To observe and describe the color of a sample of matter, you don't have to change its chemical composition. This doesn't involve any sort of chemical change or chemical reaction. Likewise, with temperature, we can take the temperature of a sample of matter without altering its chemical composition. This also includes perhaps less obvious examples like solubility. We describe solubility, which is the ability of one substance to dissolve in another, or the extent to which one substance can dissolve in another at a particular temperature and pressure. For instance, we say under normal conditions, room temperature, normal pressure, the table salt, highly soluble in water. This is, in fact, a physical property. It does not involve any change in chemical composition, physical property, solubility. Within the category of physical properties, we see two important subcategories: what are referred to as extensive properties and intensive properties. We're going to start with extensive properties here. Extensive properties are physical properties that are dependent on the amount of substance present. So this would be something like, for instance, mass. Mass is dependent on the amount of matter present. So if I have, let's say, a glass of water that's half full, I zero out the glass, I fill the glass half full with water, take the mass, add water to fill the glass to its full capacity, take the mass again, the mass is going to change. The mass depends on the amount of water present. It's an extensive property. The other category of properties then would be intensive properties. And you can probably guess where we're going here with intensive. These are independent, intensive independent of the amount of matter present. So this is maybe a little bit trickier. We have to think about properties that won't change depending on the amount of matter present. A good example would be density. So sticking with the water example, water has a density of about 1 gram per milliliter volume. So if we have 50 milliliters of water, it's about 50 grams approximately. But the density itself is that ratio, the ratio of mass to volume, and that ratio is independent of the amount of water that is present in the sample. If I have 10,000 gallons of water, the density is still going to be 1 gram per milliliter. If I have a single milliliter of water, 1 gram per milliliter, the density is independent of the amount of substance present. So we see extensive versus intensive properties here, two subcategories of physical properties. So whereas physical properties can be observed without changing the chemical composition of a sample of matter, chemical properties actually describe the ability of a substance to change its chemical composition, either by combining with other substances to form new substances or by breaking down into new substances via the process of chemical change. So when we think about chemical properties, this would include things like, if we think about iron, iron has the ability to rust, so iron rusting would be an example of a chemical property. This is a type of chemical change, chemical composition is altered in the process of rusting that is characteristic of iron. You can also think about silver. Silver has the tendency to undergo a chemical change in the process of tarnishing. So silver tarnishing would be another example of a chemical property. The silver has the ability to undergo this tarnishing process. And again, here we see these chemical properties describe a change in chemical composition, the ability of a substance to undergo this type of change in chemical composition. So we've seen that we're interested in describing the character properties. We're also interested in describing changes that matter can undergo. And similar to our previous discussion, these changes fall into two major categories: physical changes and chemical changes. So let's take a look at these two categories. In a physical change, we see the substance is altered, but the chemical composition of the substance remains the same. There's no change in the chemical makeup of the substance as a physical change occurs. So the most common type of physical change that we'll work with in honors chem would be a phase change. All phase changes are examples of physical changes. So this would be, for instance, melting, right? Melting is a phase change. This would include freezing, opposite of the process of melting. This would include sublimation, where we go directly from a solid to a gas. And there are, of course, other phase changes as well. But in each instance, we're altering the substance, we're changing the physical state of matter, but we're not actually changing the chemical composition. So let's use the example of H2O. We think about liquid water. We put liquid water into an ice tray. We put the ice tray into the freezer, and the water solidifies. It goes from liquid water to ice, from the liquid state of matter to the solid state of matter. But it's still the same chemical composition. It's still H2O. We have not changed the chemical composition, but we've altered the substance. So we see that phase changes are examples of physical changes. All phase changes are examples of physical changes. By contrast, a chemical change involves a change in the chemical composition of a substance. So we see that a sample of matter is going to be broken down to form new substances, or A single substance will combine with other substances to form new substances, changing the chemical composition of the original substances in the process. We talked about chemical properties not long ago. We looked at the example of iron rusting. This property of iron describes a chemical change that iron can undergo. Same thing with silver tarnishing. Now, chemical changes can be hard to spot if you don't know what to look for, but lucky for us, in many cases, there is some sort of observational evidence that can be collected to support the claim that a chemical change has taken place. So, in our laboratory experiments, this would include things like color change. If we combine substances or heat a substance and we see a color change occur, that's good indication that a chemical change has occurred with this substance, that the chemical composition of the substance has changed as well. Other observational evidence that we might run into would include production of a gas. If we mix substances and we see a gas being produced, bubbling in our solution, this production of a gas is likely to indicate the production of a new substance. We've changed the chemical composition of our original substances. We also could have formation of what we call a precipitate. Now, a precipitate is a solid substance that's formed when we mix two solutions. And this all depends on solubility, but the formation of a solid precipitate is an indication that a chemical change has occurred. We could also see production of heat. Many chemical changes, nearly all chemical changes, involve some sort of energy exchange as well. So this could involve production of heat or even consumption of heat, which is going to lead to temperature changes in the surroundings or the environment around that chemical interaction.